So part two, let's just go up through um, 28 and let's skip these four. They're not terribly important. The ones like 23, 25, and 27, you might see in a trig class. The ones below it, I don't think you'll really see in a trig class. These are tricky. Once the first group of problems, there were no plus signs or minus signs in either the numerator or the denominator, and I could just multiply by an exact copy or several exact copies of the denominator to get these things simplified. Not the case for this. Like if I wanted to do problem 24, because it's a square root and it doesn't have any variables or letters, my calculator probably knows how it should reduce. My calculator says this is supposed to be, for 24, I can write a fraction that's equal to the original fraction that doesn't have a square root in the denominator, and that's what it should equal to. It looks more complicated than the original fraction, but this fraction and that fraction are equal because I entered it on my calculator, I hit the equal sign, my calculator produced a fraction that was equal, and this is actually the answer for 24. I just need to get there by hand. And by hand, if the denominator has an addition or subtraction, I need to multiply the numerator and the denominator not by an exact copy of the denominator like I did with when there wasn't adding and subtracting. I have to multiply by the conjugate of the denominator. So in 24, to get to the answer, I have to throw the denominator in a parentheses and multiply the numerator and the denominator by not just the denominator, but by the denominator's conjugate, which is a denominator with its sign flipped. So the big difference why this is in a whole group of different set of problems, the plus in the denominator makes me multiply by something really different. Now in the numerator, I just go 4 times 6, which is 24, and 4 times minus 3, which is minus 4 square root of 3. You can see that in my numerator. The denominator, I do 6 times 6, which is 36. I do 6 times minus rad 3, which is minus 6 rad 3. So I'm doing 6 times 6, 6 times minus rad 3, and then rad 3 times 6, which is plus 6 rad 3. That's the plus rad 3 times 6. And then plus rad 3 times minus rad 3, which is minus rad 9. In the denominator, these conjugates cancel. I shouldn't have probably even multiplied them. And I'm left with 36 minus the square root of 9. And the square root of 9 is 3. And then 36 minus 3 is 33. So for these chunks of problems, 23, 24, 25, 26, 27, and 28, which we're going to do, because of the addition in the denominator, I have to multiply by the conjugate. Usually, we don't do these kinds of problems with cubes or fourth powers. Let's just do 23 together just to make sure we can, because it could be a little bit different. So in 23, the problem is 5 over 3 plus square root of 2. I'll check this on my calculator in a second, but I'm going to start off by multiplying by the conjugate of the denominator. I'm going to throw the denominator in a parentheses. Conjugate just means change the sign. In the numerator, I'm going to do 5 times 3 and 5 times minus rad 2. 5 times 3 is 15. And 5 times minus square root of 2 is just minus 5 square root of 2. In the denominator, I do 3 times 3, which is a 9. 3 times minus rad 2, which is minus 3 square root of 2. Positive square root of 2 times 3, which is positive 3 square root of 2. There's the canceling I needed to get. And positive square root of 2 times minus square root of 2, that's minus square root of 4. I can't combine the terms in the numerator because for adding and subtracting you need the same radicals. In the denominator, these pieces cancel. This is minus square root of 4. It doesn't look so well there. And so what I'm left with is 15 minus 5 square root of 2 over 9 minus square root of 4, which is 9 minus 2. So I think my answer should be 15 minus 5 square root of 2 over 7. Let me enter 23 on my calculator to make sure. So fraction 5 over 3 plus square root of 2. And I get 15 minus 5 square root of 2 over 7. That feels perfect. I almost feel like 25 is harder than 26 because the denominator comes out to be a -1. Let's do 25 together. Maybe you pause the video and try it. In 25, I'm going to throw the denominator in a parentheses, and if there's a plus, I multiply by the denominator with a minus. If there's a minus, I multiply with the denominator with a plus. I need to change that sign. So I'm going to do the numerator, which is going to be 2 times square root of 2. And I'm just going to leave those next to each other. And 2 times square root of 3, so the numerator is 2 times square root of 2, 2 times square root of 3. The numerator is just 2 square root of 2 plus 2 square root of 3. The denominator, it's square root of 2 times square root of 2, which is square root of 4. Square root of 2 times square root of 3, which is positive square root of 6. Minus square root of 3 times positive square root of 2 minus square root of 6. And minus square root of 3 times positive square root of 3 minus square root of 9. Always when I'm multiplying conjugates, I get canceling, and I really shouldn't do all 4 multiplyings. I should only do the multiplyings that don't cancel. So what I'm left with in the numerator is 2 square root of 2 plus 2 square root of 3. And in the denominator, I have this square root of 4, which is 2. Those cancel, and that minus square root of 9, which is minus 3. This is going to be 2 square root of 2 plus 2 square root of 3 over minus 1. My calculator won't leave that for an answer. My calculator will do this. My calculator will say, well, this is really the same as 2 square root of 2 over minus 1 plus 2 square root of 3 over minus 1. It will divide 2 by minus 1 and get minus 2. It might give me that. And because plus a minus is the same as a minus, this is getting too deep. My calculator will likely give me this. I would live with this for an answer. But this is a proper simplification. Anytime we have a fraction and there's only one term in the denominator, it's legal to separate each term in the numerator and separate them over the denominator. And then these numbers are both outside the square roots. I can reduce them. Positive divided by negative is a negative. And this is probably a better version than the original problem. Let me just bust this out on my calculator. So this problem was 25, which is fraction 2 over square root of 2 minus square root of 3. And my calculator gives me exactly, well, it flip-flopped the order that I had. So you could also flip-flop this order. It's just programmed my calculator to, I think, write the bigger radical first. But it doesn't matter. It's not any more or less right than what I had written down here. Ugly. And a little more ugliness left. I'll do 28. You can do 27, and we'll be done with this section. For 28, the problem, well, for 27, if you can't read it, it's square root of 3 over 2 minus square root of 3. It's a little bit different than mine. In fact, let me just change mine. Well, I don't need to change it. It doesn't matter. For 28, I'm going to put the denominator in a parentheses. I'm going to multiply by the conjugate of the denominator, which is the denominator with its sign changed. So I'm going to make that minus as opposed to a plus. On 27, you're going to multiply but with a plus. Now I'm going to do the numerator. In the numerator, I do the square root of 5 times 8. Those are one outside a radical, one under a radical. I just leave them written next to each other. And next multiplication, positive rad 5 times minus rad 5. Positive times a negative is a negative. I multiply the 5's together. In my denominator, I do 8 times 8, which is a 64. I do 8 times minus rad 5, which is a minus 8 rad 5. I do a rad 5 times 8, which is a plus 8 rad 5, and a positive rad 5 times a minus rad 5. That's a minus rad 25. Always when I'm dealing with conjugates, I'm going to get some canceling. So in my denominator, I have a 64 minus the square root of 25. The square root of 25 is just 5. Ultimately, I should write that down. So I'm almost done. I'm going to clean up my numerator. My numerator, it's going to be 8 rad 5. That's going to stay. And this piece, square root of 25, is just 5. In the denominator, the 64 is going to stay, but the minus rad 25 is going to be minus 5. And I'm going to write this as 8 square root of 5 minus 5, and simplify in the denominator to get a 59. I don't know if that's exactly what my calculator would do for number 27. Oops, for number 28, but let me see. So for 28, if I did this on my calculator, fraction square root of 5 over 8 plus square root of 5, my calculator gives me almost the same. It just flip-flopped the numerator. It wrote the negative 5 first and the 8 square root of 5 second and put a plus sign in front of it. If you're not owning this calculator, let me just do 27 for you on my calculator so you have an answer to shoot for. 27, it gives me 3 plus 2 square root of 3, which is kind of a surprising answer. I think the denominator comes out to be 1 on 27. That's why it's not a fraction. But you're shooting for this for an answer. You're shooting for 3 plus 2 square root of 3 for problem 27. And when you start problem 27, you're going to multiply the numerator by 2 plus square root of 3. You're going to put the denominator in a parentheses and multiply it by 2 square root of 3. And you'll find out that when you multiply the denominator, it comes out to be 1. And when I do it by hand, sometimes my answers come out backwards from my calculator. Probably, if I was doing this by hand, well, I might get 2 square root of 3 plus 3 and have the order different. So this could be an answer for 27. That's equally a good answer for 27. And give it a go and see where you get. If you really feel motivated, you can try the problems 29, 31, and 33, but I wouldn't test on them, and you're not required to do them.